Hello everyone. In today's video I will be going over the graphing transformations review. This is in preparation for our quiz tomorrow. This will be quiz 2-2, where we're practicing graphing transformations and then some more with identifying transformations. There are 4 problems total. For number 1, we have y equals x minus 6 squared plus 1. I'd like to add as I'm going through this. There are parts of this question that I have added to help you in the thinking process that unfortunately will not be a part of the quiz itself. So this first one is the parent graph and the shape. Those are not going to be on the quiz. The other items we won't have on there. We do have the vertex on there, but we don't give you like an already halfway filled out point, if you will, where it's set up with the symbols. You'll have to do all of that. It will just say vertex, and then there will be a space here for you to write your answer. And then the last item, this is one of the most important items, we will not provide you a T-chart. You have to remember to draw one yourself. So just an FYI. So first thing you want to ask yourself when you're graphing is, what does the parent graph look like? The parent graph is just the squared, so y equals x squared. We call this a quadratic, and it has a U shape. It's very important to know what shape you're going to be drawing, because if you graph it and it doesn't look like that, that means you made a mistake. Transformations, this comes from looking at the H and K spots. So H, remember, always has this negative of some sort, so you have to take the opposite. So it's actually a plus 6. And H is left or right, so if it's actually a plus 6, that means it's right 6. And the other one, the K, is a plus 1. In K, you read exactly as it says. So if it says plus 1, this means up 1. So that's my transformation, right 6, up 1. On top of that, that's also our vertex. It's the same as the transformation. Right 6, so it's a positive 6, up 1, so it's a positive 1. Now that we have our vertex, we're going to put that in the center of our T-chart. And then we need to find 2 other points on the graph. So I'll go ahead and graph the 6th one. So we go right 6. I think that's 6. I'm going to check. Yes. 6 and then up 1. Whoops. I wasn't supposed to put a point there. So just 6, 1 right here. Ignore that point. Now we need 2 more points, because we need to form the U. So the vertex is the bottom of the U. Now I need a point to the left and a point to the right so I can draw it. So I'm going to use 5 and 7. To get the y values, I need to plug it back into our equation, our given equation here. So our equation is x minus 6 squared plus 1. Now we just plug it in. So for 5, we have, and I'm going to organize my work this way so I can just carry my work down. I see a lot of students like to work that way instead of across. So we have 5 minus 6 squared plus 1. 5 minus 6 is negative 1 squared. Negative 1 squared, remember, is negative 1 times negative 1. And negative times a negative is positive, so this is 1 plus 1, which is 2. And x equals 7. Plug it in. 7 minus 6 squared plus 1. 7 minus 6 is 1 squared plus 1. 1 squared, 1 times 1 is 1, plus 1 is 2. So these are my 3 points. I'll graph the other 2 I just found. 5, 2, and 7, 2. Now I have enough of a graph to where I can draw the U. And make sure this looks U-shaped. So I'm going to draw in pencil what I don't want to see. I know it's very easy to just draw this straight, but if it has a V shape, that's an absolute value. We already have that. So definitely at the bottom, you want to round it out to go up to the point. Take your time with that. At the very least, don't have it jutting straight out like that. That's definitely a V shape. We don't want that. So for the arms of the parabola, have them curving upward like that. not perfectly straight. Not like straight out. More of a U. Okay. Now we have a few more questions to answer. Domain, range, x and y intercepts, those will all be asked on the quiz as well. Let's start with domain. Those are our x values. And that's when we move from left to right. So going left to right across the graph, we want to see what values of x are included. Now, we don't see much of the graph here because we have such a small view of it. I do want to show this, and I'm going to exaggerate this a lot. But this arrow right here is moving up, but also towards the left. So, again, exaggerating, it's eventually going to work its way all the way over here. This arrow is moving up and right, so again, eventually it's going to work its way over here. So basically, all of these points on the left side of the graph they do connect to a point on the parabola. It's just a lot further up than we can see. So this is going to help in our domain test. So when we're moving from left to right across it, all of these points are going to connect all the way up here. We just can't see it. So it's a continuous graph with a solid line. Then we get to the piece that we can see. Again, we're looking at just x values here. We've still got solid points, so we keep going. And then it's going to go to infinity on the right. So this is a negative infinity to positive infinity domain. There's no holes, jumps, breaks, nothing out of the ordinary. Range is our y values, and we move from bottom to top, looking at the y-axis. So we start at the bottom of the graph and we work our way up. This time we're looking at just the y values. When we go up the graph, there's no arrows pointing downwards, so we're actually not going to start at negative infinity. We need to move until we find the bottom of the graph, which is right here, where y equals 1. So that's the start of the graph on the y-axis. So we have 1 with a bracket since there's a point there. And then we follow it up the rest of the way, and as you can see, this graph is going to infinity. So that's our range. X-intercept or steps if we have multiple. That's where the graph crosses the x-axis. Hopefully you can see that this graph does not cross the x-axis at all. So the answer here is none. Lastly, we have the y-intercept. The y-intercept is where it crosses the y-axis. Now this time, we cannot see where it crosses, but hopefully you do believe, and again, my exaggerated line here shows, this is eventually going to cross the y-axis, somewhere up much higher than where our view of the graph is. But just because you can't see it doesn't mean you can't find it. You absolutely can. How we're going to find it? If we are looking for a point on the y-axis, we know that x is 0. Because in order to be at any of these points, x has to be 0. That's true. So if we plug in 0, we'll figure out what y is. So we're going to make our point. X is 0, what is y? So just like with the t-chart, we're going to plug 0 into our equation. So we have 0 minus 6 squared plus 1. 0 minus 6 is negative 6 squared plus 1. Negative 6 squared, remember, that's like negative 6 times negative 6 plus 1. Negative 6 times negative 6 is positive 36. Plus 1 gives us 37. So 0, 37 is our y-intercept. Next problem. Here we have an absolute value. So our parent graph. Remember, the parent graph is what you have when you take away all of the transformations. So the original graph was just y equals the absolute value of x. Shape. Absolute value has a V shape, V for value. Now let's look at the transformations. Here we have a plus 1 on the inside, meaning this is going to be left or right. And we do the opposite. So if that's a +1, that means this is actually a -1. So this is a left movement. So left 1. -4, this is up or down. And we follow it exactly. That's a -4, so it's down 4. So again, that goes with -1, -4. And that's going to be our vertex. Now we put our vertex in the middle of the table. And I'll go ahead and plot that point. -1, -4. So to form the shape of the V, because right now I have the bottom of the V, the vertex, I need to find a point on the left and a point on the right. So if I'm at -1, I need to use -2 and 0. Now to get my y values, I just plug it back into the equation that we are given. This one up here. So we have absolute value of x plus 1 minus 4. So if x is -2, we have -2 plus 1 minus 4. Be extra careful here, guys, with the absolute values. I'm already seeing a lot of students try to fall into some bad habits here. -2 plus 1 is -1. I'll see students write that, and they won't drop down that absolute value sign, and that changes the answer. Remember, it's the absolute value of -1 minus 4. Absolute value of -1 is a positive 1. Minus 4 gives us -3. And now we check x equals 0. So we have absolute value of 0 plus 1 minus 4. 0 plus 1 is 1. Yes. I keep trying to write plus 4. I don't know why. Absolute value of 1 is 1, so we have 1 minus 4, which is, again, -3. And now I graph. -2, -3, and 0, -3. And then we draw in our V. I didn't tell you guys this, so it's not a big deal if you didn't draw it this way. With the absolute value, it actually is a linear graph, meaning it goes up 1 over 1 the whole time. So I'm going to draw my line through the top right corner of all of these boxes. And I'm doing this for a very specific reason, for a question I'll have to answer in just a moment. If you didn't do it, it's fine. You didn't know it. It's not something that I made a big deal about at the time. All right, domain. Again, these are the x values, and we're moving from left to right. We're looking just to see what values of x are included, so when I move this post-it note around, I'm going to hit the graph somewhere. So I'm already hitting the graph here as I go along, and I want solid line like I have right here. And it's just going to keep going to infinity. There were no jumps, holes, or breaks there for the x values. So this is comfortably from -infinity to positive infinity. Range is our y values. So it means we're going from bottom to top. We start at the bottom and work our way up. Starting at the bottom, I'm not running into any graph here, just blank coordinate plane. The first sign of the graph is right here at -4 on the y-axis. So that is going to be the start of my range. And there's a point there, so I'm going to put a bracket. And then we follow the graph. Now we got solid line jutting out on both sides. Keep going. We hit arrows, meaning they're going to keep moving up the y-axis to positive infinity. I meant to draw this earlier, but if you need a refresher on where your infinities are. Negative infinity on the left, positive on the right, negative on bottom, positive on top. Two more questions. These are going to be really easy to answer on this problem. X-intercepts, we look at where it crosses the x-axis. This is why I wanted to make sure I drew this properly. We look at where it crosses the x-axis, that is here and here. That is at -5 and +3. When you write these, you have to write them as points. You can't just list the numbers that I just said. If you do that, we will not count it. So we have 2 points. If it's on the x-axis, that means y is at 0. So this time y is 0, and then I have the numbers for x. They were -5 and +3. Finally, my y-intercept is right here, 0, -3. And now I'm done. Halfway done, 2 more problems. Here we have y equals 2 times x plus 5 squared. Parent graph is y equals x squared. So we got the squared in there. Shape, again, is a U. Transformations, we have 2 of them. We have this 2 out in front here. We just learned this week, so it is still feeling pretty new. But remember, when you have a whole number in front that is bigger than 1, that creates a vertical stretch. Of 2. And then we also have the plus 5 in parentheses. When we have the x plus 5, we read this as a minus 5, so that means left 5. We don't have any transformations on the outside, so we're not going to move it up or down. For the vertex, though, we will want to think about this outside number. Since there's nothing written there, that does mean it's actually just a 0. So my vertex is -5, 0. And then I put that in the middle of my chart. On the graph, that's going to be right here. And then I need 1 point to the left and 1 to the right. So I have -6 and -4. Let's find them. My equation is 2 times x plus 5 squared. So we have x equals -6. 2 times -6 plus 5 squared. 2 times -6 plus 5 is -1 squared. -1 squared is a +1. So it's going to give me 2. X equals -4. 2 times -4 plus 5 squared. 2 times -4 plus 5 is +1 squared. 2 times 1 again gives me 2. Now I graph the other 2 points. -6, 2. And -4, 2. Now I have enough for a U. Again, be careful. Make sure it comes out to be a U and not a V. At least do your very best to make it obvious you're not trying to draw a V. So to be intentional here and make this round. And then just kind of jet it up a little bit. Maybe not quite that much. That was a little exaggerated, but you get the idea. Okay, domain and range. Domain is your x values. We're moving from left to right. Now let's check. As we move across the graph, again, let me remind you, a lot of the domain we cannot see because of how small of a window we have here. But this is heading to the right. So I'm just going to draw it practically straight. This arrow is going this way, eventually. And this arrow is going this way. So keep that in mind. So move from left to right. I'll be hitting graph here, way up here. I can't see it. Then I hit my actual graph, which is all solid line with points. Continue on the part I can't see. It's still going to keep going to the left. Sorry, to the right. So again, here we just have negative infinity to positive infinity. Range. It's where we have our y values, and we move from bottom to top. start at the bottom of the graph. It's completely blank. There's no arrows pointing this direction. We are not starting at negative infinity on this graph. Reminder, negative infinity is just down here. Positive infinity up top. So as we move, we don't have any graph yet. We don't hit graph until we hit the x-axis, which is 0 on the y. So we start at 0, and then we go up the graph, and now we're hitting solid points and solid line. And it points up, so it's going to keep going to infinity, meaning my range is 0 to infinity. 0 has a bracket. Since it is included, it's a point. Infinity has parentheses, always. X-intercept. We can actually clearly see this one. It sits right on the x-intercept at negative 5, 0. And that's the only one. Y-intercept. Again, we have a situation here where we can't see exactly where that is, but we can very clearly see this line will eventually head there and cross this axis. Let's find out where. Wherever this crosses the y-axis, that's when x is 0. Because to be on this axis, x has to be 0. So if x is 0, what is y? Let's plug a number in and figure it out. Plug 0 in and figure it out. So reminder, we start with just our equation, which is 2x plus 5 squared. So for x, I'm going to put the 0 in. Two times 0 plus 5 is 5 squared. Order of operations here, be careful. It's not 2 times 5 first. Please excuse my dear Aunt Sally. We're at e. Exponent goes first. 5 squared, 5 times 5 is 25. And then now 2 times 25 is 50. So my y-intercept is at 50. One more problem. Y equals negative absolute value of x minus 2. Parent graph, we have an absolute value function. Looks like a V, V for value. Transformations, we have 2 of them. So remember, this is just a before and after. So before, we had just the absolute value. So we look at what's been added. We have a negative in front, and we have a negative 2 in the back. Let's look at what those things tell us. The negative tells us that it is a reflection and again, this is over the x-axis. That's the first item. Second item, that minus 2, it's not inside of the absolute value. So let me demonstrate very quickly for those of you who still struggle with this. If we have it inside with the x, we're going to interpret that as plus 2, so write 2. If it's completely outside of the absolute value, it's supposed to be a minus, what is with me today? Absolute value of x minus 2, this is up or down. So we read this as down 2. And this is our scenario. Down 2. Vertex. So this time, we don't have anything on the inside with the x. That first number, that's our vertex. Meaning we don't move left or right, so our first number here is 0. And I can rewrite the equation here to make this make more sense. Negative x plus 0 minus 2. 0 is our h, negative 2 is our k. Since 0 is 0, it's neutral, there's no sign on it, you can't change to a negative 0. It's still going to be 0. And then k is exactly as it is, minus 2, down 2. Going to put that vertex in the middle, 0, negative 2. Going to go ahead and graph it. 0, down 2. Now I need a point to the left and a point to the right to make the V. So I need negative 1 and 1. Now let's find the y values. Here we have negative absolute value of x minus 2. So let's see what happens when x equals negative 1. You got to be extra careful with this one. Negative absolute value, x is negative 1 minus 2. Negative absolute value of negative 1 is a positive 1 minus 2. So this is negative 1 minus 2, which is negative 3. Now let's try 1. Negative absolute value of x, which is 1, minus 2. Absolute value of 1 is 1, so we have negative 1 minus 2, which again is negative 3. Let's graph these other 2 points. Negative 1, negative 3, 1, negative 3. Reminder, I meant to point this out earlier. Because of this reflection over the x-axis, remember a reflection is going to flip it over the x-axis. So now this v is going to point downward, which is what I have going on here. Now I'll just graph the v. All that's left is to answer these 4 questions at the bottom. Domain, our x values, we move from left to right. And we have our infinities, negative on the right, positive on the left, negative on bottom, positive on top. As we move from left to right, we hit an arrow, so this is heading back towards negative infinity, so we're covered there. We're going to follow it. We've got solid line with solid points. It's looking good. And then it's going to keep going to the right to positive infinity. So once again, we have negative infinity to positive infinity. Reminder, this is not always going to be your domain. It just happens to be what the domain is most of the time. But there are many examples, we can give you plenty, where this is not the case. So be careful with it. Range is our y values. Move from bottom to top. This time we do start at the bottom and see arrows pointing back at us, meaning this graph starts much lower than what we're looking at. It starts all the way down at negative infinity. So keep note of that. Get onto the graph and we're hitting solid line, which is good. We hit solid points, and then we come to a stop here at negative 2 on the y-axis. And if I look ahead, there's nothing else. This is the end of the graph. So it goes from negative infinity up to negative 2. Negative infinity gets parenthesis, negative 2 gets a bracket since it's a point, and that is that. X-intercepts, let's look. X-axis is right here. This graph, entire graph, is below the x-axis. It does not touch it. None. Y-intercept, looking at the y-axis here, it clearly crosses at 0, negative 2. And that is all. So I hope this was a great review for the quiz. It's definitely give you a chance to practice some of these different transformations and graphing points. It feels like students are really getting the hang of it, which is very awesome. I'm really happy to see it. Besides these problems, the only other type of problem we'll give you, it'll just be one sentence. It will say, here's your function, what are the transformations? And then you would, for this one, write right 6, up 1. That's it. You don't have to graph it. You don't have to tell us anything else about it. All you have to tell us is, looking at this equation, what is the transformation? Well, that'll be all that is on the quiz. If you have any additional questions, feel free to email me or come see me in person before you take your quiz. Otherwise, I hope you have a wonderful day. Bye.